This is a 2013 paper, question 2. You can pause now and read the question if you don't have it in front of you. We can see that this question is going to be about the normal distribution. It's referring to blood pressure of the students, and we're told that if this is the blood pressure and we were to draw a graph of it, that it would be approximately bell-shaped, with a few at this end, a few at the top end, most in the middle. We're told that of the students there is a mean of 113. There's the unit, and standard deviation is 10.3. Right, so part 1, what proportion of the students chosen at random blood pressure between 113 and 120? So 120 is going to be to the right here, 113, and the probability of having a blood pressure in between there is the same as the area under the curve between those two values. So we want the probability of choosing a blood pressure, having a blood pressure between 113 and 120 if we chose a random student. So normal distribution. In CD, we've got a lower bound of 113, an upper bound of 120, standard deviation of 10.3, and a mean of 113. We get our answer of 0.2516 to 4 dp. Right, part 2. (719 students, how many? This is a how many question. So to answer a how many question we need a probability, and we'll multiply that by 719. How many would be expected to have blood pressure less than 115? So here's my mean, standard deviation. 115 will be just to the right. We want the probability, or how many students would have a blood pressure less than that. So that's all of those students there. Probability of having a blood pressure less than 115 will be the same as the area under the curve below that value. So looking up on our calculator, we need the probability of a value being less than 115. So we're going to need a lower bound of something really small, and we usually choose negative infinity. Negative something like that, and the upper bound is 115. Everything else stays the same. We get 0.5769. We're going to multiply that by 719, so that's just over 50% chance of a student having a blood pressure less than 115. Closer to 60% of students actually, which is what it looks like. So we want to find that proportion of the 719. It's going to be just over half the students. And multiplying that out, we need to do some rounding because it's a number of students. (414.79 ... and now let's do some rounding. We'll round that to 415 students. Approximately. Or 414 would be fine too. So that's how many we would expect to have a blood pressure less than 115. Part 3. Probability that 2 randomly selected blood pressure readings from students are both over 110. So back to our curve. 110 this time is on the left. We want the probability of a blood pressure reading being over that amount. Once again, it's more than 50%, 50% to halfway, so it's going to be more than that. So let's find the probability of have a reading greater than 110. We need a very big upper bound, 0.61457. So that's the property of one student. Now we've got two students, both being that. So the probability will be that. So that's the first student and the second student is also. When we say and in probability, it means times, multiplying them together, 0.3776 to 4 dp. Right, part 4. Retest the 10% of our students who have the highest blood pressure. So we've been given the percentage this time, the proportion. So those highest, the ones with the highest readings will be up this end. We want to retest the 10% of the highest one, so 10% is the same as 0.10. We want the lowest blood pressure value of a student that Alice will need to retest. Well, it's this value here. So everybody above that will need to be retested because their values are quite high. So I can see this is an inverse question. So this time when we choose normal, we're going to need to go inverse. It's a right tail. The area is 0.1. All the rest is the same. And we get a value of 126.2 if we do some rounding. Let's think about the units. It was millimetres Hg. So everybody with a reading of that or above is going to need to be retested, which means 10% of the school. And perhaps we better write a sentence with that. So minimum blood pressure to be retested is 126.2. Everybody above this. Everybody with a reading above this. Or equal to. Will need to be retested. Right, we can see we've got our graph here. 40 students. The first thing it's good to do with a graph is just run through, put the heights on the bars because we're going to probably need that. You can check that they add to 40. Part 1. What proportion lie between 110 and 122? So 110 is there. 122 is there. So the proportion of students out of the 40 students, 11, 12, 13, 20, 26. 26 out of 40, and we can simplify that to 0.65. So 65% actually of students have a blood pressure reading from this group. Let's check what it was. This is the group after PE, so this is students after PE. That's their readings. Compare the results for these students with the distribution of results for all the students at Alice's school. So we know that the distribution for all students was approximately normal, with a mean of 113 and a standard deviation of 10.3. What would be interesting to do is to find the probability for this group, it's the whole group, of having a reading between 110 and 122. I can see for these students it was 0.65, so I wonder what it is for these ones. Lower bound is the same, back out upper bound of 122, everything else is the same. It's only 0.423. 5 to 4 dp. So only for the whole group, the probability of someone having a blood pressure between 110 and 122 is only 42%, whereas for these students it was 65%. So there's a difference already. And the other thing we could do is we'll look at the shape. The shape of this one doesn't appear to be very normal. In fact, perhaps a bit more of a skew down this way, so skewed to the higher values rather than normal. If you remember, the mean for the whole students was actually 113, which is down here. With a normal distribution, the mean is the same as the median and the mode, and you can clearly see that 113 is not going to be the mean or the median or the mode for this particular distribution here. If we wanted to find out where the median was, there's 40 students altogether. Half of 40 is about 20, so it's about where the 20th student would lie. There's one student here, another one here, 6 there. So 1 and 1 is 2, and 6 is 8, and 7 is 15. So the 20th student is in fact going to be somewhere in here, between 120 and 122. So that would put the median of this group somewhere in here. Now the other thing we could do, only if you have time in the exam, is to find the mean and the standard deviation for this group here as well. Using your calculator, we estimate the actual reading of this one student here by using the midpoint, which in this case would be 111. So we're estimating, because we don't actually know what the student's reading is between 110 and 112, we'll estimate it with 111. So these values along the x-axis go in the x column, and the blood pressure readings go in the other one. So just to show you, so down here it's the first value, and then it's all the odd numbers from there on in, enter them all. Over here, one student there, and now there were 0 students had a reading in there. Got to be careful. 1 student, 6, and so on. Oh, I've missed out 117 there, haven't I? And so on. Now you can put them all in, and remembering where we go from there, we go to Calc. It's really important to make sure that we look at set and make sure that the frequency is in list 2. This is the frequency, is the y-axis. Now it's better, so that when we ask for one variable, we get the data that we're looking for. And of course I haven't put all the values in, so you can do that. And when you've done it, just check the calculator uses x bar for the mean, and it uses sigma with a little x for standard deviation. And I got something like basically 120, 121 actually, and for the standard deviation a number like 4.9. We could approximate that by 5, since we're approximating obviously the values along the x-axis, so it's not going to be perfect. But you can certainly see the mean is a lot higher than the mean for the original whole group, and the standard deviation is a lot lower, in fact half the standard deviation of the whole group. So you need to write some sentences. We'll compare shape. Now we've done this calculation already. This value is a lot lower than that from the PE students, where the probability that they were between 110 and 122 was 0.65. I think that's just up above there. Right, notice about shape. The PE students group appears to be more skewed. the higher values than for the whole group. Then more skewed than normally distributed. That's what we're comparing. The mean for the PE students is a lot higher at approximately 120 compared with 113. We better use a unit. For the whole group. Similarly, the median is a lot higher too. It's approximately 120. In the mode for the PE group is higher too at, let's just check the mode. So the mode, we'll need a modal interval for this one. Let's look for the highest bar, and it's there between 120 and 122 as well. And put a unit in. We could comment on the spread. The spread as measured by the standard deviation is lower for the PE group. At 4 point, I think it was 4.9, you can check that up above, compared with 10.3 for the whole group. So what does that tell me? It tells me there's a lot less variation in this PE group. You'll need to write that down. I'm running out of space. This means there is a lot less variation. There is smaller spread and variation about the mean for the PE group. I'm sure there's other things you can write too. Right, still going. One more question. You can pause and read it. Year 13 students, standard deviation is now 9.8. 1/3 of the students have a blood pressure above 124. Find the mean. So we're looking for the mean. It's clearly an inverse type problem. These are my readings. And we're told that 1/3 have blood pressure above 124. So the question is, where is 124? Is it down here or is it down here? Probably someone is above that. Probability of students having a reading above that is 1/3. So the question is, can that area be a third, or can that area be a third? And clearly halfway, 50% would be this much. So there's no way that all of that in there could be a third. This can't be where 124 is, because that is a lot more than a third of students having a reading above that. So it clearly needs to be on the other side of the picture, on the other side of the mean. So 124 must be here. The probability of students being higher than that is 1/3. So if we go to a calculator, there's a right tail, the area 1 divided by 3. Standard deviation is now 9.8, but now we have a problem because there is no mean. So this is one of those questions where we're going to need to use a curve where we do know the mean and the standard deviation, and that would be the 0, 1, z standard normal curve. The value of 124, we need to find what number 124 translates to. So now we can use our standard deviation of 1, mean of 0, and we get a value of 0.4307. The 124 has been transformed to 0.4307 using the formula, which will be on your formula sheet on the z curve. So for x, on the x curve the number is 124, we don't know the mean, standard deviation, and the value on the z curve that 124 corresponds to is 0.4307. Now we've been solving this using solver on the calculator, remembering brackets around here. We can do it by hand. We get a value of 119.78. Just check that that number is in fact to the left of 124, which it is. So the new mean .78, put it in a unit, remembering units for excellence.